Now the speed of a trajectory is the magnitude of its velocity vector. So if r of t is this, given on the left, its velocity will be the derivative of r, which will be deriving the first one, coordinate, x coordinate with respect to t. I use the product rule, so that will be 5 times e to the t sine t plus 5 e to the t cosine t, comma. Repeat the same process, but now with cosine. So derivative of the first times the second, so plus the first derivative of the second, which is minus sine. And then the derivative of 5 e to the t is just 5 e to the t. So that is the velocity. The speed is the magnitude of velocity. So we need to calculate the magnitude of this. So it's the square root of each of those terms squared. When I square this, I'll get the square of that plus the square of that. So 25 e to the 2t sine squared t plus 25 e to the 2t cosine squared t plus 2 times this times this. So 2 times this times this. So that will be 50 e to the 2t sine t cosine t. And when I square this one, the calculation will be exactly the same, except I'll have a negative sign, which only carries over to this spot. So I'll have 25 e to the 2t sine squared t plus 25 e to the 2t cosine squared t minus 50 e to the 2t sine t cosine t. So this cancels out with this. I'm trying to use my red color there. There you go. And then the last term is just the square of this. So that will just be 25e to the 2t. The good part now is that this, when grouped up with this, if I factor out the 25 e to the 2t, I'll get 25 e to the 2t times sine squared plus cosine squared, which equals 1. So this guy here just equals, just notice all of this is inside the square root, okay? So the first highlighted part is just 25 e to the 2t. The second highlighted part is also equal to that because they're the same. So in fact, we have this times 2. And then the last term that we did nothing with, which was plus 25 e to the 2t. Look at that. There's 3 times 25 e to the 2t. So that means this is 3 times 25 e to the 2t. This root 3 can stay inside of the square root, but this can all come out to give me a 5 root 3 e to the t. So that is the speed for t associated to that trajectory. To find the length, what we do is we integrate the speed. So the length is the integral of the speed for the time interval given, and we're told that t is supposed to vary between 0 and the ln of 3. So that will be antiderivative of 5 root 3 e to the t dt from 0 to ln 3. These are constants, so they can come out, and I can just antiderive e to the t, and this antiderivative is just e to the t, because the derivative of the exponential function is the exponential function. Since this is a definite integral, I don't need to bother with the constant c. So all I do is I plug in ln of 3. So e to the ln of 3 that's 3. So that's 5 root 3 times 3 minus, now plug in 0 to get e to the 0th, which is 1. So 5 root 3. So that is 15 root 3 minus 5 root 3, which is 10 times the square root of 3. And that is the answer. That is the length of our curve.